Hello, sir.
Hello, Adam. How are you today?
I'm good, sir. How are
Doing good.
you?
Thank you for asking. Okay,
Yep.
hold on. Let me find okay, so what are we doing today?
Um, is it okay if we go through another like past paper?
Sure, let me look for a few past papers first. Hey, um examiner report question paper. All right, let's do a question paper from November 2021.
Okay, sir.
All right. Let me see first if we've done this paper yet. This one is done. Yeah, I think we're done with this one. Okay. November.
Can you hear me clearly, sir?
Yeah, I can hear you very clearly.
Okay.
How about me? Can you hear me?
Yeah, I can hear you.
All right, good. Uh, let me see. Still looking for a good for the paper we haven't done yet. Okay, I think June
But a
2022.
lot of papers.
Yeah, that's a lot. I think we've
Oh,
done.
sorry. There is one topic. There is one topic.
Okay, go ahead. What topic was it? Can't quite recall. Hold
I
on.
want to focus more on magnification.
Magnification. All right. Okay, sure.
No, not magnification. I mean like what's it called?
Lenses,
It's like mirrors,
mirrors, and
lenses.
lenses,
Yeah,
right? Okay.
yeah.
All right. All right. Let me just check real quick. What the exact thing is here. Okay. Okay, that looks like unit 6, which is uh okay, wait, that's under waves. Okay. Let me just see what exactly do we need. I think will definitely be needing lenses, but let me see if we need to do mirrors too. Yeah? Give me like a
Okay.
minute more. 7, 6. Reflection, sound waves, electromagnetic properties, uses lenses. Okay, according to this, we only are doing lenses. Well, we have lenses, then
Yeah,
visible
okay.
light. Okay, we don't really have mirrors, but okay, we'll in that case we'll just do a flat mirror, yeah, or a plain mirror. Okay, so let me
Yep,
just.
sounds good.
All right. So let me just share the Jamboard now. So while this is happening, what do you know about these topics now? Mirrors and lenses.
Like, what do you mean by? Do I have to give like definition or?
Like what exactly do you know? Like definitions or like how you can construct the diagrams for it or whatever. Anything you
Uh,
remember.
I mean the maths, like exactly the how to find the angle
Okay,
to
that's
which
for.
it's being reflected on.
All right, so that's reflection, correct? Anything else?
Uh, I probably do. It's just that I don't know how to like
Oh, okay.
say the exact
All right. So first of all,
definition.
in that case, let's do mirrors first, okay? What to be specific,
Yeah,
plane
might as
mirrors.
well reset on the topic, like review, like
Yeah.
to revise on the topic. That's it.
Okay. So what we'll do is I'm gonna look for. I'm gonna discuss this briefly, and then afterwards we'll do some questions. Yeah. So of course, plane mirrors. You already know the equation. If you have a plane mirror, basically you have a flat mirror, right? There's your mirror here.
Okay.
Okay. And then you shine a light on it, like a ray of light, like this. And
Oh,
then
sorry,
you.
you're not sharing your screen.
Hold on. Yes, thank you. Let me share my screen. And let me share it on the camera as well. Okay, there. So if you have a plane mirror like this, okay, and okay, and you're measuring, okay, let's do this quick. Let's measure that. Let's say that this is at right angles. This is the normal. You call that normal, right? Okay, and then you're measuring this
Okay.
angle, say, this angle. Let's say this is angle I. Okay, then that light, as you said, as you mentioned, will be reflected at an angle R, so that I equals R, right?
Yeah.
Okay, so that you already know. Let me just go through a few properties here that included here. Okay, so not only that, but the three rays, the two rays rather, two rays and the normal are all on one plane, single plane. Okay, so that's one more thing that normally is not mentioned, but you know it could come up. Okay, but having said that, because of this fact that this equation exists, this is a pretty easy um fact to remember, right? Okay, so let's go quickly through the other one, lenses. Okay, so when you have lenses,
Okay.
okay, when you have lenses, that means light bends, right?
Yeah.
Okay, so we're gonna have to go through the idea of refraction first. So when light bends, remember that if you have a surface again, and but this time instead of being just reflected, you have a light ray, and then you also draw the normal, like so, and then you're gonna have your light ray bend like so, right? Let's say that this has a
Okay.
refractive index Ni, and then this is I, and then this has a refractive index Nr, and I'm gonna use that with a capital R, and this is the way we measure the R. Okay, then what's the rule that you remember? What's the equation
About
here?
reflection and refraction.
Yeah, for refraction.
Equation of refraction.
Yes. If you
Equation of refraction is it do I call it an incident index?
okay, right? The index of
Okay,
refraction of the incident,
index.
okay, times,
Yeah. Times sine of the incident angle,
right?
and then you go to the refracted incident
Okay, so NR, correct?
equals to the refracted times sine refracted angle.
Correct. So this should be easy enough, right? Um, okay, so again, since you recall the equations, or at least you're familiar with the equations now, let's go straight to lenses before we do the exercises here. Okay. Wait. Shall we do lenses first or
I
the other
just
one
took it
first?
from my notes. That's it.
Okay, that's fine.
The formula I got it from notes. Yeah.
Okay, that's fine. There is one more concept that we want to go through: total internal reflection. Yeah.
Yeah.
Okay. Do you remember this? Okay.
Total internal reflection.
If you don't quite recall that, that's fine. Let's just set it up. Okay, so this time around, we're gonna do the opposite of the previous case. This is still Ni. Okay, and this is still Nr. Okay.
It's the movement of light rays, right?
Yeah. So what happens here if you strike this at a particular angle, and what will happen is it will totally reflect. Nothing will be refracted. Okay. So 100% reflected.
Okay.
Okay. Now that means this is I, of course, and this is R, right? We'll use the small r again for reflection like this. Okay, but the one thing about here is you can consider this to be, let's use a different color. You can consider that light to be actually be refracted this way, wherein that angle is 90 degrees, and this is the refracted ray R, right? So if you think about this, if you apply the law of refraction or Snell's law here,
Yeah.
you're gonna get just Ni sine I, right? If we apply that, we're still gonna do this, and R sine R, right? Sine big R, right? But we know that R is 90 degrees. So this will be, let's replace that R with 90 degrees. And what is the sine of 90 degrees? That's just 1, right?
Sine of, yeah.
Okay, so from here, what's gonna be sine I? Sine I will be equal to the ratio of the indices of refraction, Ni, like that. And from here, we can just do that as I.
Your internet's really...
You can just say that I is equal to sine inverse of that ratio, right?
Sir, can you hear me?
Yeah, I can hear you. Can you see it? Is it clear?
Your internet's very poor right now.
Oh, okay. Hold on. Let me check.
Just your voice was completely like distorted.
Okay. All right. How about now? How do I sound now?
Yeah, now it's better.
All right.
Just when you were talking, it completely like crashed.
Okay. So anyway, you are following the Jamboard. You're following what I'm writing, right?
Yeah, I'm seeing.
Okay. So basically, this is going to be the equation for total internal reflection. This I here is called, we can change this I to this angle C. So we'll call this C here, right? Now, what's the C here? The C is the critical angle. This is the minimum angle. Okay. So let's just write here, C is critical angle. Okay, and this is defined as the minimum angle so that total internal reflection can happen. Okay, so the critical angle is the minimum angle for total internal reflection to occur. Okay.
Okay.
If the angle is smaller than that,
I'm just writing this now.
yeah. If the angle is smaller than this, then you have some refraction happening. Okay. Now, when does this occur? Total internal reflection happens. Reflection occurs when light is traveling from a denser medium, high N, to a less dense medium, low N. Okay?
Okay, I'm just gonna write this down.
Okay, go ahead. Alright. So that's the second part. Tell me when you're done, and then we'll do lenses real quick. Okay?
Okay.
Alright. While you do that, I'm gonna check what else we need in lenses. We need to draw, but we don't need to calculate. All right. So according to what we need here, no need to calculate anything for lenses. We just need to draw the diagrams. Okay. The difference here. Oh, I see the difference. You know, this is a little bit more complicated than in the Cambridge GCSEs. Yeah, the Cambridge GCSEs only focus mostly on actually both convex and concave lenses. Never mind, it's the same. It's just focusing on the diagrams. Okay. All right, tell me when you're ready. Okay. I think you... Okay, so let's move on then. Lenses. Okay, let's just do converging lenses first.
Okay, sure.
All right. Converging or convex lenses. Okay, we've kind of discussed this before. But let's do this briefly. The symbol for a convex lens is like this. Let's use a black one. Here. Convex lenses are basically like that. Okay, that's the symbol. The other kind of lens, the diverging or convex lens. Okay, so let's do a side-by-side comparison. Converging or concave lenses. Okay, the symbol would be a little bit different. The symbol would be the arrows are pointing inwards like this. Okay. Now, how do you remember this? It's easy to remember this for the convex lens because basically they should form the shape if you carry it on. Yeah. Similarly, you should form the shape like this. Okay. All right. So okay, so let's take a look first. Let's take a look now rather on the next properties. So every lens, converging or diverging, will have its center point like this, right? And we'll just define that as the center point, and then you can make a line either way through that center point, right? And then on either side of the lens, you will always have a point. Okay, you will always have a point, and this we'll call this point F, and it will call this distance big F. Similarly here, this is again your small f for the diverging lens, and this is also big F. Okay. Now in most lenses, in all lenses rather, you will have another focal point on the other side. Okay. Now for the lenses that we're gonna use in this course, let's just use this. That's also F. The thing is, these two distances are the same. That's also F here. Okay. Similarly, here you'll also have a second point here, F, and that's also going to be the same distance, big F here. Okay. In real lenses, they may not be the same value, these two F's. Okay. But for our purposes for the course, we'll consider them equal. Okay. What do these mean? Small f is called the focal point or the principal focus. Okay. And that distance f is called the focal length.
Just writing this down.
Okay. F is the focal length. Okay. In both of these cases, that's what they mean. Okay. Now, for our purposes, we're not really gonna be interested too much in the focal length. Okay. What we wanna do here is see what's gonna happen. See how we should draw our diagrams. You're gonna draw your diagrams like this. Okay. Okay. Tell me when you're done first before we proceed with the diagrams.
Okay.
All right. Let's continue. So converging lenses will again always you will always form the image for a converging lens like so. So let's say that that's the converging lens here, and let's say that's the focal point F, right? And that's also the focal point F. Okay. And now let's say that we have an object here. That's our object. Okay. Let's make the lens a bit bigger. Okay. Okay, so that's our lens, and it's a converging lens. So the idea here is always that the light is converging. So what will you do whenever you have, let's draw the first ray. So again, we've discussed this before, but the first ray is always gonna be like this, ray 1. It's always gonna follow this path. Okay, I'll just put a note here. Ray 1 is parallel to the axis, or let's say perpendicular to the lens. Then is bent to F once it passes the lens. Okay.
Okay.
Like that. Okay, so that's ray 1. Okay. Ray 2, you will always draw 2 or 3 rays. Ray 2 is this. I'm going to use yellow for that. Ray 2 passes like that. Okay.
Okay.
All right.
Yeah.
Ray 2, what can you notice in ray 2? Ray 2 passes through the center of the lens. Does it bend or not?
Yeah. Can I say it passes through origin or?
Yeah, you
No.
can say, I wouldn't really say origin, I'd say center of the lens. But yeah, that's the idea.
Center of the lens.
Yeah.
Yeah.
Passes straight through the center of the lens, right?
Yeah.
Does it bend or not?
No.
And does not bend. Okay. All right, so that's ray 2. Ray 3, let me label ray 2 first, like that, right? If I do ray 3 is gonna be the opposite of ray 1. It passes through the focal length, through the focal point first. And I did a pretty good job here, okay? Of drawing, if I may say so myself. All right, the reason is because this point of intersection is pretty good. All 3 intersect there, right? But before we go there,
Yeah.
ray 3 passes through the other focal point, right? Ray 3 passes through the other focal point. And then is bent so that it is perpendicular to the lens. Perpendicular to the lens. Okay. All right, and then what do we do here afterwards? The fourth thing we need to do, and this is also true for diverging lenses, these 3 rays, okay? The last thing you're gonna do is where the image is. Image is formed where the rays intersect. Okay, that's it.
Okay.
All right. So here's so in this case, it doesn't matter whether we're using diverging or converging lenses. So if we do this with a diverging lens, we're gonna do the exact same thing. Okay. So let's draw the lens here. Lens here and lens here. Let's put the object here. About the same position here. That's the object, and let's label the F's. It's the first F. That's the second F, right? Okay. The thing about this is for diverging lenses, you're still gonna do the same thing. The easiest one to draw is ray 2, right? So I'm gonna draw ray 2 first. Ray 2 is just gonna do that. Okay. All right. How about ray 1? Ray 1 is, we're gonna still follow the same rule. You start perpendicular to the lens first, and then when it passes through the lens, it must pass through the focal point. But because of the idea that this is a diverging lens, the way it will move is gonna be something like that. Oops. It's gonna look something like that. Okay.
Okay.
All right. Again, because of the fact that it's a diverging lens. Okay. So similarly, since we went through this focal point here, the third ray, which is red, in our case, is going to pass through the other focal point first, like that, right? And then it's going to go straight like that. So what we'll do is we'll make this little thing here a dashed line. So we just know where it's passing through. And again, the image will be formed. I'm going to form the image with black again. So the image here will be here. The image here will be where they all intersect, and it's gonna be somewhere here. Okay?
Sir,
Yes.
I wanted to have a question. Since it's like 5:30,
Uh-huh.
I want to ask, can we use the other 30 minutes for a past paper?
Yeah, I was gonna do that because this is the last thing. This is the last thing here. Every other thing from here on out is just an
Okay.
effect of these rules in lenses. Okay. All right.
Okay.
So, okay, you wanna use, okay, I think it's gonna be easier if we focus on specific questions here, right? So let me look for a few questions to make it faster. I'll just look rather than make my own, yeah?
Yeah.
Let's do lenses. Okay, questions. All right, I'm gonna take these questions straight away from the BBC bite-sized questions, which is basically the BBC's version of revision, right? Okay. Let me see. Oh, these are all multiple choice. Okay, let's not do that. That's multiple choice. Let's look for structured questions first. Okay. Convex, concave, real and virtual, magnification, calculating. Okay, not this one. Let's see if this is gonna work.
Are we doing structure questions?
Yeah, I think so. There should be. Okay, here we go. So I'm taking this from studysquare.co.uk, yeah? So here's the first question. I'll post it on the Jamboard. Okay. So let's do lenses, because I think this is gonna be the one that's hardest to do anyway. Okay, so okay, never mind. Sorry, that's not the stretch. Okay, so sketch a ray diagram for a concave lens where the object is between 1 and 2 focal lengths away. So I think, okay, I'll remove this. I'll just do this part. So sketch this ray diagram here. So okay, here we go. The object is between 1 and 2 focal lengths away from the lens. So basically what you're gonna be asked here to do is, you're still gonna draw your lens, but where are you gonna put the object?
Are you asking me now?
Yeah. So let's say that this is F, the focal length, right? And this is 2F. Okay, I'll rather write it like that. So where would you put this object? It's between 1 and 2 focal lengths away. So here in section A, section
put it in
B,
between.
or C?
B.
Okay, you'll put it in section B. Okay, I'll do this now, and I've made you editor on this Jamboard already. So what I want you to do now is try to make the ray diagram for this object. I'll make it a bit smaller. Like this. Okay? Okay, this is the object. I'll label that as O. Okay, so... Okay, I'm not giving you the other F, so you just need to draw 2 of the 3 rays here. Okay? Alright. Have I given you the link yet? I have, right?
I'm checking.
Yeah, I have. I just did.
Okay.
Okay.
Just fixing my screen so I can open chat.
Okay.
So would it be like object is here, this
Uh-huh.
is the lens here?
Okay. I still don't see your drawing here. Let me... But I see you're logged in already. Okay.
Would it be like
You're in slide 4, right? Okay, there, I see you. Okay, something like that. You have to make it... You have to make it, you know, keep going. Okay, and then the second part...
okay.
And then the second part is it will always start from the tip of the object. So it will not go, it will not start at from any random point. You always start from the tip of the object here.
Oh yeah. Got it. It's just I don't have my mouse right with me
Okay.
right
In
now,
that case,
so
that should be fine. Okay, so how about the second ray? Okay, I'll just do the correction right now. But yeah, I'll do that right there. Okay. So how about the second ray?
Okay. Yeah. Like going straight like that.
Okay. That would be true for a concave lens. Oh, sorry, not a concave, a convex
Okay,
lens. That would be true for a convex lens. If you're doing it for a
Yeah,
concave,
convex lens.
if you're doing this for concave, you have to go this way first. Alright? And then, remember in
Okay.
convex you go this way?
Yeah.
In concave you go the opposite way. So you have to do that.
Okay.
Okay?
So for a concave lens, I'll go straight.
Yeah. Go straight and then go back. Okay?
Got it.
Alright. For convex, you go straight, then move forward. Okay. Alright. So where would the image be? The image would be...
Image would be presented.
Okay, hold on. I think I made a mistake on that.
It's just convex and concave lenses was a weak point for me, so it's a bit hard for me to understand.
Alright. Hold on. I think I better redo this one because something's wrong with the diagram. Okay. I'll just... Oops. Just erase your drawings here. Control Y. Okay. I may have made a small mistake, but let me correct that. Okay, we still draw the ray 2 the way we did. So it's still gonna be this. Yeah? Okay. The thing for concave lenses is that you must form an image somewhere else. Okay. Hold on. Let me figure this out real quick. Something is wrong with the way I'm doing it. Okay. Right. Okay. Okay, so that's how it would look like. So yeah, the image would be here. The image would be here. Yeah. So I'll label that I, and this is O. Okay. Okay. So all right, so let's do another problem, this time with some values. Okay, now the magnification, just let's go through that briefly. The magnification of a problem, not a problem. The magnification would be how big the image is. So let's put this here. So magnification is the size of the image compared to the object. Okay, this is a dimensionless number. In other words, it doesn't have a unit. Okay, now of course, what does this mean? If you put this in formula form, this is gonna become image size divided by object size. Okay, so again, this one is pretty straightforward. Okay. So here's a problem here. Okay, so calculate the magnification of the lens given that the object has a height 1.2 and the image has height 25 millimeters.
Calculate. Okay, just putting it into my calculator. I don't have a calculator on me now because I'm not in my house.
Oh,
That's
I
why I'm
see.
just typing it in.
I see. All right. Well, yeah. Just tell me the numbers you need to calculate. I'll just write it down and then you can do the actual computations later. So what's the equation we need to set up here?
That's okay. I already have it open.
Okay. That case so, should be fine.
No problem.
Okay. Okay, I am streaming this into YouTube again in case you want to refer back to this. Okay.
Okay.
So what number do you get?
Could you give me just 1 second? So I have to convert them both into millimeters, right?
Yeah. Or you can convert the millimeters to centimeters. Either way should be fine.
Yeah. So would that be 120 millimeters?
Uh-huh.
So 120. So 25 millimeters over 120.
Okay.
So 120 divided by 25.
All right. Actually, first of all, that's not 120. That's only 12.
Sorry.
That's 1.2 centimeters, not 12 centimeters. Yeah? Remember that 1 centimeter is 10 millimeters. So in this case, it's going to be image size. So this is the image size, 25 millimeters. Object size is 12. So you have to do 25 over 12. Okay. And that's going to give you that's gonna give you 2.08.
0.48. Sorry, yeah, 2.08.
Okay, to 2 sig figs. Okay, great. All right, so next we're gonna do a more concrete example. This time we have a converging lens. Okay, so here's the problem. This is gonna be more concrete because this is a real life example of lenses. Okay, so there's a camera. Paula bought a camera for her birthday. The focal length of the camera is 60 meters. Given that an object is placed 130 meters away and the camera has a convex lens, sketch a ray diagram to show that image formed. Okay. All right, I'll help you here by drawing the diagram. Okay, so if this is the lens.
Okay.
Okay, if this is the lens, let's make the lens a bit big. And it's a convex lens, so we'll symbolize that by that. Let's say that this is your 60 meters. That's the focal length, right? So your object is gonna be somewhere here. Okay. So how do I know that? Because 130 meters away is more than twice this distance, right? So let's just say that's the second location. So yeah, that's more or less it. Okay. So again, tell me how to draw the diagram so that we can just go ahead. Or you